All right, the next topic is organic chemistry, and it's based around carbon. Carbon's a non-metal, so it forms covalent bonds with other elements. It has 6 electrons, 2 in the first shell and 4 valence electrons. So in order to have a full outer shell, it can attract 4 more electrons, and it forms 4 bonds. So each of its valence electrons can form a bond with either another atom, so up to 4 atoms, or a couple of bonds with individual atoms. The most common element that carbon bonds with is hydrogen, and the simplest molecule that it can make is methane. So methane is when you have 1 carbon and it's bonded to 4 hydrogens. You can see that they're sharing 2 electrons, so that there are 8 electrons around the carbon, so its valence shell is full. Hydrogen has 1 electron in its outer shell, and it can have another one, so that there's 2 electrons in the first shell. So if it shares with carbon, it also has a full valence shell. So the formula for methane is C1H4. Rather than using electron dot diagram from now on, I'll use a structural diagram. And I've drawn it to show that it's a tetrahedral structure, so that 1 up and 3 down. This is the first in the series of alkanes, so I'll draw the next one for you. Okay, rather than the one of the bonds being to a hydrogen, I've replaced that hydrogen with a carbon. This carbon also needs to have 4 bonds with other elements. So the other bonds are with 3 hydrogens. I've drawn this to show that they're tetrahedral, so it would be 3 down, 3 up here. But from now on, I'll just draw them simply. The formula is C2H6, and the second one is called ethane. So from now on, instead of drawing them as they are, tetrahedrally, I'll just draw them like this simply. The next one in the series of alkanes is propane, which I haven't written on. These, when it's drawn out like this, it's called a structural formula. The simplest way of recording this is that you have 3 carbons and 8 hydrogens. Another way, a very useful way of referring to propane, is to do a semi-structural formula. So as you go along each of the carbons, you write what's attached to that carbon. So the first carbon has 3 hydrogens attached to it, the second carbon has 2, and the third carbon has 3. So it's CH3, CH2, CH3 is a semi-structural formula. Okay, so alkanes have single carbon-carbon bonds. And if they have single carbon-carbon bonds, then they're said to be saturated. So if you asked for a definition of saturated, you can't just say it has single bonds. You have to add this carbon-carbon bonds, because this is a single bond here, but this is not the reason that it's saturated. These single bonds here are the reason that it's saturated. So anything with the name, the end of the name, ane, means that it's a saturated hydrocarbon, an alkane. You need to know the names and the formulas of these, and you need to know the prefix, because these prefixes are going to be used for all of the further organic chemistry that we'll be doing. So meth, eth, prop, but, pent, MEP, BP. Once you get to pent, ane, everything else after that, and I'll show on the next slide, is based on the shape names. There's a pattern to how many hydrogens go with the number of carbons. So as you're working your way along a chain, every carbon needs 2 hydrogens. So whatever number carbon you've got, you multiply that number by 2. So for 5 carbons, multiplied by 2 is 10. And then the last carbons need an extra hydrogen so that they have 4 bonds. So you add add 2 for the ends. So whatever the number is, multiply it by 2 and then add 2 for the 2 hydrogens on the end. So the alkane with 6 carbons is hexane, 7's heptane, octane is 8, like an octopus, nonane's 9, sounds like 9, and decane is like a decade. So these ones, hex is like a hexagon. These ones should be easy to remember.